Our homework tonight is helping us get into segment proofs. So these are going to be proofs that involve line segments. So they might involve pictures of line segments or explanations of them, but it's going to have to do a lot with properties of segments. We're also going to rely a lot on the properties of equality. So remember our properties of equality, that's all what we're in that foldable. So we have our commutative property, we have associative property, identity, inverse, all that good stuff, but then we have some new ones this year. So remember our new ones were the reflexive, POE, and I put POE for property of equality as opposed to writing it out. And reflexive just means that a number is equal to itself. A is equal to A. The next one is the symmetric, POE. And the symmetric property just means that if A is equal to B, then we can switch the position of A and B on each side of the equal sign and make it say B is equal to A. And lastly, we have transitive. And the transitive property of equality says this. If I know that A equals B and B equals C, then A is equal to C. So those are our properties of equality. So when we get into segment proofs, we not only need to know these properties of equality, but we also need to know what we call properties of congruence. So this is our next part, properties of congruence. And I'm going to refer to these as POC, just like with properties of equality, I called them POE, properties of congruence. So before we talked about the reflexive property of equality. Well, now we're going to talk about the reflexive property of congruence. So remember the reflexive property of equality says that A is equal to A. Well, we're not talking about equality, we're talking about congruence. So what this says is a line segment like AB, and we label it with our line segment detail, is congruent to itself, AB. So for any segment AB, and I didn't mean to put the comma right there, for any segment AB, this is true. AB is congruent to AB. Just means every line segment is congruent to itself. Remember that sign? That means congruent to itself. So that's our reflexive property of congruence. Now let's talk about the symmetric property of congruence. All right, symmetric property of congruence. So remember our symmetric property of equality, if we're thinking about equality, so don't write this because I'm going to erase it in just a second. It says if A equals B, then we can switch those terms around and say that B equals A. And we can just switch them around. So all we're doing is we're creating a line of symmetry at the equal sign and then moving whatever is on the left to the right and whatever on the right to the left. So we can do this around a congruent symbol. So what it says is segment AB that's congruent to segment CD. If this is true, then we keep that congruent symbol and we just switch them around. So AB was on the left, now it's going to go on the right. CD's on the right, now it's going to go on the left. So if AB is congruent to CD, then CD is congruent to AB. And this is for any segments AB and CD. Just means that it's true for any segments. So that's our symmetric property of congruence. We had the next property of equality that we talked about was transitive, so that's what we're going to talk about here. Transitive property of congruence, okay, POC. So remember our property of equality, so don't write this. If A is equal to B and B is equal to C, then A is equal to C. We're essentially going to do this, but with congruent symbols, and we're going to talk about segments instead of letters. Okay, so here's what it says. If AB segment is congruent to CD segment, and CD segment is congruent to EF segment, then segment AB is congruent to segment EF. So given that those two statements, we can come up with that conclusion. So that's our transitive property of congruence. I don't know about you guys, but this makes me think a lot about the law of syllogism. It's not exactly like that, but it's kind of connecting those two outer parts. So those are our properties of congruence. And along with the properties of congruence, we need one more really important thing for segment proofs, and that's the definition of congruence. So we're going to write this down, definition of congruence. And I know it might seem kind of silly to write down the definition of congruence because we've been talking about congruence in our class all year. You've been talking about it in math classes for years. But the definition of congruence, it's sort of like a property. It's a reason that's going to be you're going to be able to provide to justify something in a proof. Okay? Here's what the definition of congruence says. It says, segments are congruent if and only if they have the same measure. Segments are congruent if and only if, so we should be thinking biconditional statement, they have the same measure. So let's think about segments. Given segment AB and segment CD. Okay. If segment AB is congruent to segment CD, then AB, whenever I don't put a bar on top of AB, I'm just talking about its length. Then the length of AB is equal to the length of CD. This is a biconditional statement, so we're going to say the converse as well. If the length of AB is equal to the length of CD, then the segment AB is congruent to the segment CD. So I want us to notice something here. We may have talked about this before, but it's really important when we start getting into proofs. Anytime you use a congruent symbol, that means you are talking about a figure. So you're saying that segment is congruent, or lines are, lines can't necessarily be congruent, but you're talking about a figure, or an angle is congruent. You're talking about a figure itself. Whenever you talk about equals, you say two things are equal. We don't say that a segment is equal to another segment. We would say that a length. So this is a length or a measurement. So that's why we'll say, like, length, we just say AB. We don't put the segment bar over it. Or a measurement, we might say the measure of angle A, something like that, not angle A. Angle A is a figure, segment AB is a figure. Okay, so there's a big difference between statements of congruence and statements of equality, and that's why we have properties of equality and properties of congruence. Even though they're very, very similar and they might be referring to the same figure, it's expressing it in a slightly different way. Now, in our notes, we've talked about all these new properties of congruence, but your homework tonight is still going to be applying properties of equality. So remember, we have the addition property of equality, we have subtraction, division, and multiplication. And these are all properties of equality. You might also see substitution. All right, so these can all be applied to segments. So I'll give you an example. Let's say I have segment AB, or I have the length AB is equal to the length of CD. Okay, watch what I do in this next step. Now I say AB minus EF is equal to CD minus EF. So I'm talking about the lengths of segments. I'm not just talking about variables here, but what changed from step 1 to step 2? Well, if we take a look, it looks like we subtracted EF from both sides of that equation. So we used, and notice this is an equation, it's not saying congruence, it's talking about equals. So what property says that we can subtract a value on both sides of an equation? That's going to be our subtraction property of equality. Okay? I'll give you another example. Let's say that AB is equal to CD. So that's one step that's given. And then in the next step, I say AB plus 2 is equal to 7. Okay. In the next step, I say CD plus 2 is equal to 7. And my question is, what happened from step 2 to 3? Well, let's look at what changed. I had AB plus 2 equals 7. CD plus 2 equals 7. So what changed was AB became CD. So what property would allow me to say that I can replace AB with CD because I know that they're equal? That's going to be substitution. So that's how we would justify that. And you could say substitution or substitution property of equality, because those two things are equal. So try your best on the homework tonight. I want to see what you can do, and then we'll go over it next time in class.